Welcome to Spring LIB.
Hello students, in this question there are two subparts in this. That is, in the first case, volume is given, that is 5.25 liters. Mass of helium is given, that is equal to 3.22 gram. Then mass of nitrogen is given, which is 11.56 gram. Temperature is given as 15 degree Celsius. So 15 degree, first convert this into Kelvin. 15 plus 273, which is equal to 288 Kelvin. So in the first case, we are asked to find out the total pressure. So for total pressure, first we will calculate moles of helium. Mass is given and we know the molar mass. So moles is mass upon molar mass upon molar mass. So we substitute the value, that is mass is 3.22 gram divided by molar mass, that is 4, is equal to 0.805 mole. Then moles of nitrogen is equal to 11.56 divided by 28 is equal to 0.4126 mole. So total moles is equal to 0.805 plus 0.4126, which is equal to 1.218 mole. Now we use the ideal gas equation to find out the pressure, that is P is equal to nRT upon V. We will substitute the value, which is, that is pressure is equal to 1.218, R is 0.082, temperature is 288 divided by volume, that is 5.25. This comes to 5.49 atm. That is the first part which is asked, that is total pressure is equal to 5.49 atm. Now in the next part of the question is asked the partial pressure of nitrogen. So partial pressure, we take it with small p, is equal to moles of nitrogen divided by total moles into total pressure. So we will substitute the value, that is moles of nitrogen 0.4126, total moles is 1.218 into 5.49. This comes to 1.86 atm. So partial pressure of nitrogen is equal to 1.86 atm. Now in the second part of the question, volume is given as 1.50 liters, pressure is given as 3.62 atm, temperature is given as 30 degrees Celsius, and mass is given as, that is M, is given as 9.62 gram. In the first case is asked to find out the density. So density is equal to mass upon volume. So we will substitute the value, that is mass is 9.62 divided by 1.50, which is equal to 6.41 gram per liter. In the second part of the question is asked to find out the molar mass. So using the ideal gas equation, we can find out the molar mass, that is pressure is equal to density upon molar mass into R into T. We will substitute the value, that is molar mass is equal to density, that is 6.41 divided by pressure, that is equal to that is equal to 3.62 into R 0.082, and temperature, that is 303 Kelvin, which is equal to 44 gram per mole. So molar mass is equal to 44 gram per mole. Now, in the next part of the question is asked to find out the molecular formula for this. So as it is given saturated hydrocarbon, so these saturated hydrocarbon, they have a general formula CnH2n plus 2. So molecular mass of carbon is what? That is 12 into N plus hydrogen, it is 1 into 2n plus 2 is equal to 44. So 12n plus 2n plus 2 is equal to 44, or n is equal to 44 divided by 14 is equal to 3. So it becomes C3H8. So the molecular formula is equal to C3H8 for the saturated hydrocarbon. Thank you. Hope you have found the video useful.